Dear viewers, in this video I'm going to explain about how to draw isometric view or isometric projection in the AutoCAD software. So before going into the exercise, so I will give a short intro about isometric projection. Okay, so isometric projection, it is a technique to represent 3D objects in a 2D platform. Okay. So the whatever drawings we make, we will draw it in a paper. Okay, paper is a 2D platform. So in order to represent any 3D objects in 2D platform, it is very difficult. Okay, so this isometric projection, this techniques helps you to draw any 3D objects in a 2D platform. Okay, so this is exact reverse or exact vice versa of this orthographic projection. So in orthographic projection, a 3D object will be splitted into 2D objects based on the surfaces that can be seen from different orientations. Okay, if you see this, so if you take this object based on the surfaces, okay, which we see at different orientation is splitted into front view, top view and side view. Whereas if you come to this isometric projection, okay, based on this 2D surfaces given, so we have to come up with a three-dimensional object. Okay, so this is an example here. So where this orthographic projection, this is converted into an isometric view. So next we will see this conventions and scales that are involved in isometric view or projections. Okay, so based on the dimensions, the scales which we are using, it is classified into two types. One is isometric view and isometric projection. So if you are drawing this isometric if you're drawing this representing this object 3D objects, okay, at a true length, okay, then we will call it as isometric view. So if you are using isometric scale where the true length will be multiplied with a common factor of 816, so here I rounded to 0.82, the exact number is 0.816. so if you are multiplying the length with this 0.82 and if you are drawing the drawings, then we call it as isometric projections. Okay. So this is an example. So this one corner of the object should be placed on this axis in such a way that two sides should be rotated at 30 degree, okay, with respect to horizontal axis, okay, this horizontal line. So we can also have a coordinate system here. Okay, this so the objects should be aligned with all these three axes. Okay, so I'm going to take three axes, putting this coordinate at the corner of this object, okay, which is lying on the horizontal line. Okay, this we can take x, can take y, and this we can take z. Okay, so the object should be aligned with all these three axes. Okay, so this axis, two axes should be rotated at 30 degree, whereas one axis should be placed vertical. Okay, so the object should be placed on this axes, should be aligned with this three axes. Okay. So now we will see an example. Okay, so first we'll take the first one as a hexagonal prism of base side 30 mm and axis length 60 mm is resting on HP on its base with the side of base parallel to VP. Draw the isometric view of the prism. So here they are asking the isometric view. So we have to draw it at the true length, okay, true scale, actual whatever the length of the object, we have to draw the isometric view for the same length. Okay. So before going into this drawing this 3D objects straight away, first we have to come with the 2D projection, this orthographic projection for this object based on the given condition. Okay. So first I will get the front and top view for this object, okay, based on the given condition. From that 2D view, we will convert it into a isometric projection, okay, isometric view. Okay. Go into the software, click new. So first I will set the window in drafting and annotation. First set the units. Okay, so I'm going to set it in millimeters. Limits, so I'm going to take A3 size as my limits 0, 420, 297. Then zoom all. So first I will make the orthographic projection, this front and top view for the given object. Okay. Place the text. It's going to be X. It's going to be Y. Above the line BP, below the line HP. So first we have to identify where we have to draw the true shape. Okay, based on the condition given. So the object is hexagonal prism. It is resting on HP on its base. Okay, then you can able to see the true shape. Here the true shape is hexagon, so which you can able to see when you see from the top. Okay, so first you have to draw the true shape. So in the top view we can able to see the true shape. Top view we have to draw it on horizontal plane. Okay, the one condition is given that a side of base should be parallel to VP. So for drawing this polygon, so hexagon I will use this polygon command. Okay, number of sides 6, edge. So you have to place the hexagon like this because one side should be parallel to VP. Okay, so in this orientation only you can achieve that condition. Okay, the left side is 30 mm. So I will move this object close to the reference line. So now I will give name to all the corners. Okay. So as it is a prism, we have to give two sets of corners. So for bottom face corners, I will give PQRST. For top face corners, I'm going to give ABCDEF. Okay. So A within the bracket P. So what B within the bracket Q. So within the bracket represents it is a hidden corner. Okay. So the bottom face corners are hidden corners when you see from the top. So I'm representing within the bracket. Okay, C. D within the bracket S. Here E within the bracket E. F within the bracket U. So I gave names to all the corners. Now I will project vertical lines from all the corners in order to get the front view. So project first you project lines up to the reference line as point B and F are falling on the same line. Okay, so I'm going to take only line from F. From the center also I'm going to put a line. Okay, so this is the axis line. Okay, the line that is passing through the center of the object, I call it as axis line. So axis line we have to represent using center line type. So I'm going to load those type of lines. So once you load it, now it starts to appear here. Okay, so I will select this line and change to the center line type. So the axis length is given as 60 mm. Now I'm going to copy this line and put it at all the corners. now I'm going to connect all the center line is the axis line, so we have to change its type. Select the line. So now again I'm going to give names to the corners at the front view. So bottom face corners are P. So again Q, U is the hidden corner. Again here R, T is the hidden corner. Last one, yes. Similarly for the top face, this is A, P within the bracket F. This one C within the bracket E. The last one is T. Now give the dimension, mention the axis length, and also mention the side length. Okay, this is the orthographic projection for the given solid. Okay, so now we got the front and top view. So based on this front and top view, now we are going to draw this isometric view, which is a 3D representation of an object. Okay. So take a line, okay, draw a line, okay, draw an horizontal line. So you can take it randomly. I'm taking 150. So here for this isometric drawing, so I'm going to use a box method. So I'm going to put a box around this hexagon. So I'm going to enclose this hexagon in a box. Okay, so I'm going to put a box around this. So there is no center. So take a line. Okay, so I'm going to start from A. So now I put a box around this. So this doesn't seem straight. Okay, again I'm going to put around the hexagon. Now I'm going to transfer this box, one corner of box to this horizontal line. Okay, so before going for transfer, so I'm going to give names to this box corners. So text. So this I'm taking as 1, 2, 3. This one is 4. So now I'm going to place this corner 1 onto this horizontal line. Okay. So before that, we will measure this box length and width of this box. Okay. Length is so width is 51.96. Length, it seems 60. Yes, length is 60. So we have to place these two lines. Okay, at 30° with respect to this horizontal line. So I'm going to take at this midpoint. So switch off the ortho mode. Okay, first I'm going to place this 1,4 line. Okay, the length of this 1,4 line is 51.96. Press tab. So this side should be rotated at 30° with respect to that horizontal line. Okay, so here the software is showing the outer angle. So 180 minus 30, give 150. And then this other side also, this side 1, 2. Okay, so again it is 60. Press tab, 30. So now I got this two sides, so I'm going to get the two sides using this copy command. Okay, select this line and select this one as the base point, put it at the other end. Similarly, again you can use the copy command, select this line, enter, take this as base point. Now we have to mark all those six corners, the corners which is present on the X. Again we have to transfer all those six corners to this box here. Okay, so the A is located at midpoint of 1 and 4. Okay, this 1 4 line, the A is located at the midpoint of 1 4 line. So I'm going to utilize points option, okay, to place all those points. So A is lying at the midpoint of line 1 4. This is my point A. So now we have to transfer this point B. Okay, so I'm going to measure how far it is from 1. So it is 15 mm. Okay, so I'm going to take a line. I'm going to mark this 15 mm. So 15 tab 30, enter. So point, put a point here. Okay, from here it is located at 30 mm. So one more line from here, 30 tab 30. So this is going to be my point C. This is point B and point C. So we have to transfer this to this line. So again you can use the copy command, select both the points, okay, enter, and take this as base point and put it on this. Okay, this is going to be our corners E and F. So, okay, E, not E and F, T and U, because we are drawing the base of the shape. Okay, so one more point on this line, again at the midpoint. Now we have to connect all the 6 points. This is the bottom face of the prism. Okay. So again I am going to give names to all the corners. As it is a bottom face corners, I am going to start with P, Q, R, S, T, U. Okay. So as well as I am going to give the corners for this box. Okay. This is and also ensure that angle between the side and the horizontal line is 30 degree. Okay. So now we have to place this vertical line, okay, along this from this point 1. Okay, this should be equal to the axis length. Okay, so draw one vertical line. Press F8 switch on the ortho board. Draw it. So since we are drawing, there in the question they have asked us to draw the isometric view. That means you have to draw all the lines for the true length. Okay, so 60. So now after placing this line, select all the bottom face, all the entity at the bottom face. Okay, copy and take one as base point, put it at other end of this vertical line. Okay, so now we got the top face. Top face we have to change the alphabets. Okay, this corner is A, B, C, So now we'll connect bottom and top face corners with the help of vertical lines. First we will enclose the box. Okay. Now we'll connect all the corners. We have to connect only the visible corners. Okay. So whenever you seeing this object in this view, okay, in this 3D view, okay, so this isometric view, so you have to analyze what are the corners visible to you. So those corners only you have to, those visible corners as well as visible edges, longer edges only you have to mark. Okay, so this is U to F, this is visible edges. So after drawing this, we have to highlight only the visible edges. So I'm going to change color. So that's the thickness of the line. Only these edges are only visible edges. Okay, these edges will come behind this object, which is not visible when you see in the isometric view. Okay. So no need to connect ENT also, which is comes behind this object. So if you want, you can delete this lines also, because those are not visible. I'm going to delete. This is the isometric view for the given question. So whenever the question is given, first you have to make 2D diagrams, 2D projection, orthographic projection out of it. So front view and top view. Based on this, you have to use the box method. You have to put a box for the true shape, surround the true shape, enclosing the true shape. And you have to transfer this box to this horizontal axis in such a way that one corner should lie on this axis and two sides should be rotated at 30 degree with respect to this axis. So this is the final output. So two more exercises are there, which I will discuss in next video. So thanks for watching.